Okay, from this video onwards, we will be working on a separate playlist, okay, called Troubleshooting Splunk. So in this particular playlist, we will be seeing how to troubleshoot Splunk in various different ways, okay. We will start with Splunk internal logs, then we will be moving to some other topics like btool and other stuff over there, okay, because Splunk, like knowing how Splunk log stuffs in internal logs is very much important compared to any other debugging techniques, okay. That's why I'm starting with this one, then slowly we'll move on to some other techniques over there as well, okay. Now this is a very vast subject, so that's why like I am creating a separate playlist for this one. And if you go to my channel playlist page, so this playlist will be over there, and if you know, like I always give a sequence number to all the playlist I have for Splunk and machine learning, so just follow that one over there, okay. So let us start with the internal logs. So why we need to study internal logs? As I said, we need to basically use this particular knowledge for our troubleshooting purpose and system health check purpose as well, okay. So if I just go to the next slide, okay, so the first question arrives: what are the stuffs are getting logged into Splunk? And if you see it over there, like almost all the operations we do in Splunk is getting logged over there, okay. Like the system operations, like the data ingestion, then we are doing some kind of search, right, using SPL, and then we create dashboards. Those stuffs are also getting logged. If you do the application deployment, either using any of it, like the either deployer or deployment server, those deployments are also getting logged over there, okay. We will see how those logs looks like and how to extract knowledge from there, okay. System performance related knowledges or logs, basically even what will be the Splunk impact on the underlying hardware, okay. So that resource utilization level details also are getting logged into the Splunk internal logs, okay. Even different user activities also getting logged, even Splunk license usage is also getting logged, okay. So almost all the stuff we do in Splunk, some way they are getting logged into Splunk somewhere, okay. Now how they are getting logged and how to read those logs, we need to follow basically certain rules. So in this video I will try to establish that particular pattern over there, okay. If we understand that one, right, in the future videos whatever I will be discussing over there, it will be easier to understand, okay. Now based on this is very like functional level logging we discussed about over here, right. Now based on all these things, there are various kinds of logs are generated into Splunk. The most important are which are starting with Splunk D. As we know, like Splunk D is the main process in Splunk, right. So that's why the main log, and this is also the log we will be starting with over here as well, called splunkd.log, okay. Even the splunkd process also log into separate other files like splunkd_access, standard error, standard output, UI access, utility. So even we will try to touch base on these logs as well in future videos over there, okay. But initially we will be starting with splunkd.log over here, okay. Now apart from these logs, there are like audit logs, btool logs, configuration logs, crash logs, license usage logs, matrices logs, even migration logs. This is very much important log where if you upgrade Splunk or do some migration in Splunk, this log has been generated specifically, okay. And this log you can see it for any issues related to the migration over there, okay. For Windows specific logs, this particular log has been generated, msi.logs. Apart from that, there are scheduler logs, which is basically deals with the schedule searches. There are search logs, resource usage logs, KV store logs as well over there, okay. We'll try to see one by one. Now initially we will be, as I said, we'll be starting with splunkd.log, then we will move to some other logs over there, okay. Now to understand how splunkd logs created, okay, we need to understand how splunkd works. And if you are following my videos on props.conf and transform.conf, in those videos we have discussed many times how Splunk data is getting ingested, right? So there is a very specific data cycle, like life cycle, right? They have, if you just see it in very broad sense, they just go through this 4 phases: inputs, parsing phase, indexing phase, then you can do the search and analytics phase over there, right? Now if you see, like, the data is moving from one phase to the another phase, then the next phase, right? So this is called nothing but a pipeline in Splunk. Okay, now if you see the how Splunk internally designed, and every phase you talk about in Splunk, everything you talk about, like the data processing and everything, it's at the end of the day, it's a pipeline over there, right? So that means when you talk about input phase and when you talk about parsing phase, the data coming out of the input phase is fed to the parsing phase, right? Then the data coming out of the parsing phase is fed to the indexing phase for the indexing purpose, right? Now the data which is coming out of the indexing phase, that data is a searchable data, right? Which we can search in our dashboards and in our search prompts, right? So this is called the pipeline. And if you see each and every phases over here, okay, so each and every phase also have their sub pipelines as well. Okay, so they have different processors, and they have some kind of input, and they have very small processors. Processors is nothing but, you can say, a program unit which do a specific stuff. Okay, so let's say, like, in during parsing phase, we have a processor which basically deals with the regular expression. Okay, so that kind of stuff. So during input phase, there could be a processor which basically see how, if a file has been updated or not, then it will tail that file and it will get only the latest data from the file, and it will send it for the parsing and indexing phase for the indexing purpose. Okay, so those type of stuff. So a processor is nothing but a program unit which do a specific kind of job, and each and every phase over here has multiple sub pipelines which do some kind of stuff over here. So if we just talk about a very generic pipeline in Splunk or any place, right? So it has a input, then it has some processors over here, if you see it, right, which do specific jobs. And how two processors are communicate with each other, it's through the queue. Okay, in Splunk it is called the persistent queue. Okay, so from input it goes through the queue from the first processor. From the first processor, its output is going through the queue, feeding to the second processor, and so on. Finally it is generating the output over here. So in Splunk, every places, if you see, this particular architecture has been followed over here. Okay, so we understood the concept of pipelining over here. Okay, now this will form the base about how the logging also happened in Splunk, because the logging, we generally say it's called logging channel, because we'll see when we'll see practically in the underscore internal index, there is a field called component. Okay, now that component is basically a direct one-to-one mapping with the processors, different processors over there for each and every phase. Because if you see the input phase, let me go to the next slide, right? So if I just try to see what's going on inside the input phase, okay, it can happen that we were receiving data from multiple channels. It could be a file monitor, it could be from a script, or it could be a modular input you have written, or it could be a HTTP event collector, or it's just direct data receiving into the TCP or UDP port over there, right? Now based on all these different kinds of input, there are separate processors. Let's say for file monitor we have a tailing processor, for script we have exec processor, for modular input we have a modular input processor, for HTTP event collector which has HEC processor, we have HEC processor over there, for TCP UDP inputs we have TCP UDP processors over there. Okay, if you see, we are just only talking about the input phase now, right? And over there, if you see, there are multiple processors. That means we have multiple pipelines over there, right? Whenever we are dealing with a file monitoring, there are separate pipelines. Whenever we are working with a script based input, we have separate pipelines over there, okay, which we discussed in our previous slides over there, right? And for each and every kinds of pipeline, there are different processors are involved, right? And each and every processor log their own data, okay, and those processors actually forms the component part of the internal index over there, okay. So let's take an example of this file monitor. So today we will be concentrating on the processors related to the file monitor only, okay. In next videos we'll take baby steps one by one, okay. So if we just take the file monitor, how the processing happens. So let's say when you're monitoring a file, right? So there will be a program which basically continuously monitoring the file and see whether any update happens or not, right? Or if a new file added or not, like this kind of events, right? So it's called file update notifier, okay. Now it notifies when this particular event occurs, it notifies to a tail reader. Okay, what happens? This guy is actually responsible for reading the file. Okay, now after it reads the file, it basically checks three things over there. Okay, first thing is whether this particular file contains a archives or not. That means any zip file or not. Okay, whether the size of that particular file is less than 20 MB or not, or whether the size of the particular file is greater than 20 MB or not. Now based on that, okay, it calls separate processors. For archives, it calls the archive processor. For size less than 20 MB, it do not call any processors. It just directly send to the queue for the processing for the next phase. Okay, for size greater than 20 MB, it called the batch reader processor over there. Okay, and all this data are getting fed to the next level where we are doing the parsing, right? So basically it's moved to the parsing queue, then it moves to the parsing processors over there, which we will be seeing in future videos over there. Okay, so this is how a typical file monitor processing looks like, and the overall processor is the tailing processor over here. Okay, now if we just assign the component names, as I said, in internal index there is a field called component. Okay, so for the tail reader, the component name is tail reader. The archive processor, the component name is archive processor. For the batch reader, the component name is batch reader. And for overall processor, the component name is trailing processors over here. Okay, so let us try to explore now in our internal index and see how we can map these concepts over here. Okay, let me give you an example over here. So let me first show you the internal index. So now here one thing is, if you go to your Splunk home, okay, let me first give you that idea. If you go to Splunk home var log Splunk directory, okay, so whatever log files over here, if you see it, like all are getting indexed into Splunk. So that is the first concept we need to understand over here. And if you see, one of the log is splunk.log over here. So this is also getting indexed into Splunk over here. And the index it is getting index is called index equals to underscore internal. Okay. So this is the index where it is having all the logs which is getting indexed into Splunk. Okay. If you select the source type from here, you will be able to see the log source type. Now, when we talk about Splunk dlog, you need to select the source type called Splunk D over here. You can either do the source type called Splunk D, or from the source, if you see it, you can select this particular source over here as well. Okay, it's up to you how you will be getting that log over here. So it is always easier to do with the source type. Okay, because Splunk has provided a proper source type with the Splunk D over here. As we are only talking about Splunk D logs now, so we will be concentrating only on this particular log for now. Okay, now as I said, if you see it when you run this particular code, so there is a field called in the under interesting field, there will be a field called component over here. Okay, as I said, so the value of this particular field will be the value of the different processors which are basically involved in that particular area. Okay, so as we were dealing with the file monitoring, right, just like this is the example I was giving it to you. Okay, so let us create a input called file monitoring. Okay, so before that, let me create a new folder over here. We will try to monitor this particular folder over here. Okay, so let's say test, or let's say demo. Okay, and inside that I will create a new file, okay, called demo.txt, and let's give some data over here. Let's set 08, some dates over here, 5/20/20, then some hours. Okay, then some text over here, okay. So, and let's put another line over here, some more text over here. Okay, now we will monitor this particular directory today and see what kind of components are getting generated, or what kind of logs are getting generated over here. Okay, so what we'll do is we will go to settings, we will go to data inputs. Okay, so for files and directories we will add new. Let's browse it in the D drive, demo folder. Okay, so this demo folder only we will be monitoring it. We'll click on next, everything is fine. We will index into our main index, submit, start searching. Okay, so now if I just run this particular query for last 15 minutes, okay, now there are a couple of things. If I just see the components over here, if you see, there are certain things like tailing processor, tail reader. Okay, so these are getting generated over here. Okay, so let's see it how it works over here. Okay, so if I just say trailing processor over here component, if you see, it is giving a log called adding watch on this particular path, which we just now set it up over here, right? Even if you see, like it's actually add watch on different other paths as well, right? Over here, if you see it, like these are the files which are getting basically the log files, internal log files in Splunk, because Splunk internally added those, monitored those particular folders and log files, so it is automatically indexed into Splunk over there. Okay, that's the internal concept of Splunk. But for us, we know where to check when we have added something over here. Okay, even let us try to, okay, 1 minute, let us try to see some other stuff as well. So we saw the trailing processor. Even let's say we talk about the tail reader over here. Okay, so it is also log something over there. It will be more prominent when we'll be talking about a archive one. Okay, so let's say I created a archive file. Let's create an archive file over here. Okay, so let's say demo1, so .txt. We will add something over here. So let's say some archived text, VED archived text over here. Okay, so we created that file, and we will, let's say using 7-zip, we will make it as a tar file. Okay, and this tar file we will move to our demo folder where we are basically monitoring this one, right? So let's see now what exact processor is getting triggered over here. What kind of processor are getting triggered over here? So we are expecting our archive processor will be getting triggered over here, right? So let's do that one. If you see, the tail reader is already started saying archived file, this one updated less than 1000 millisecond ago, will not read it until it stops changing. Okay, see, it's actually monitoring it, that particular archive file over here. Now let's see whether we have the new component has been generated or not. If you see it, previously it was 8, now it is 9, and our archive processor has been triggered over here. If you see, so this is the processor which is basically reading our demo.tar file, and it is basically giving this particular data for the next phase, which is our nothing but our processing phase or the parsing phase over there, right? So this is how it works over here. And if you see, like, if we just understand how different things work, like this different input works over here, or when we'll move to the parsing phase or indexing phase, how parsing works, what are the different components, logical components are involved over there, then if we just take a look at those components over there, okay, it will all make sense, because each and every component will be basically implementing a pipeline over there, and where it will have a multiple processors over there, as we have seen in this particular slide over there, right? And those processors are basically nothing but the logging channels, okay? So those processors are basically creating some kind of components which are basically logged over here in this particular field, okay? So these are the different processors over here. So if you have batch file like this one, so if you have some files which is size greater than 20 MB, it will go to the batch reader processors and log accordingly over there, okay? So this is how it will be working, and the whole processors are monitored by this trailing processors over here, which we have seen it over here as well, right? This trailing processors, the trailing processor over here, okay? So hopefully the basic idea I am able to establish over here, okay? Now with this idea we will talk about some more logs now, okay? So we just talk about how for Splunk different Splunk inputs the logs are getting generated, right? So now if you see, like, we just talk about the not the very different inputs, just talk about the file monitoring over here, okay? In the next video maybe we'll talk about how script monitoring works and how it's getting logged over here, okay? I received so many comments on my channel, like how what I need to check when my modular input or my scripted input is getting failed, okay? In the next video we will talk about that part, okay? We will try to see internally how different processors has been set up, and then what kind of logs they are generated over there, okay? Okay, another thing, let me show you over here. As you have seen, these different processors are there, right? Now there is another component, or there is another field in these logs are called log level. If you see it, like either it's info, warn, or something like. So in Splunk there are, I think, 5 different log labels are possible. Let me show it to you over here. This one: debug, info, warn, error, and fatal, okay? Now you can basically specify the log label for each and every kind of log over here, and each and every channels of log, or basically each and every processors over here. From the Splunk web, this is how you can do it. If you just go to settings, server settings, so not everybody will be having access to this particular screen over here. Even not everybody will be having access to the internal index as well. So if you do not have access to the internal index, maybe you need to talk to your system administrator, Splunk administrator over there as well, okay? Now if you go to settings, server settings over here, if you go to server loggings, so these are the different channels over here, or different processors over here, okay? So if I just search for tailing over here, okay, if you see that tailing processors over here, right? So you can set up this logging level over here as well to debug, info, warn, error, whatever it is, okay? So also there is a way in Splunk, like when you restart Splunk, you can restart Splunk in a debug mode as well, so that it will be enabling the debug logging for all these different channels over here, okay? But just keep in mind, like, this will have a huge performance impact on your system, because the logging will be too much verbose, and it will also take more space in your system as well, okay? So that's why it is not at all recommended to run Splunk in debug mode, okay? But anyway, for each and every channel, sometimes if it is very much needed, you can come over here and set the logging level to debug and see how it's working. But generally in most of the cases, the info level loggings are sufficient over here, until and unless you are facing some kind of roadblock which you cannot resolve at all. Info level loggings are perfectly fine over here, okay? So hopefully this video was helpful. See you in next video.